Alright, so in this example, we want to look at the power carrying capacity of a rectangular waveguide. So this particular example, we have a WR340 air waveguide. Inner dimensions are given here for A and B. And for this particular waveguide, the recommended frequency range for the TE mode is given as shown, 2.2 to 3.3 gigahertz. We want to calculate the maximum peak power at the high and low ends of the recommended um, frequency range. So in other words, we want to use the breakdown strength of air as 15,000 volts per centimeter. That particular level, a safety factor of 2 at sea level is assumed. So what we want to do then is want to solve this for both 2.2 and 3.3. So first of all, to just look at 2.2 gigahertz, we basically have to find lambda. So in order to find lambda, we take the speed of light, which is the speed that we're going in air, and we divide that by the frequency, and we get 13.64 centimeters. So we're going to use this formula for the peak power. So let me go back to the presentation. We'll end this show here, and we'll go back to the PowerPoint presentation that actually from the addendum in ENON listed the formula for the peak power in the waveguide. So the peak power is basically equal to the field squared, A times B over eta times 2, and then 1 minus lambda over 2A quantity squared. So this is the formula that you're going to use in this solution. So back to the solution. Open that presentation back up. So back to the solution, you can see here's A, here's B, here's eta, here's our electric field, here's the factor 2, here's our wavelength lambda, and then this is 2 times the waveguide dimension. So this is what you plug into the formula for 2.2, the lower end of the frequency spectrum. For the higher end of the frequency spectrum, basically, instead of dividing by 2.2, we would divide by 3.3, which would give us a slightly lower number here for the wavelength, which would put a slightly lower number here, which would make this factor smaller, which would actually make our peak power slightly bigger. Then to find the maximum time average power, we basically would take, as you know, 1/2 of the peak power, because the peak power would be the maximum of the sinusoidal wave, and then the average power is half of that.